These notes are going to go over percent composition. Percent composition is basically how much of any mass of an element is in a given compound. To understand that, we need to understand molar mass firstly. So the mass of 1 mole, 6.02 times 10 to the 23rd of any element, compound, or molecule, is going to be calculated from the average mass on the periodic table. So whenever we're looking that up, it represents the mass of that many particles of that element. Just for simplicity's sake, because obviously that's a very large number, we are going to represent that as grams. And that number is going to be given to us here. Not there, this one here. Those are our molar masses. That's the mass of 1 mole of our substance. And so when we look at that, we are going to see that for this one here. That is found in the periodic table. And it's the average, if we remember, based on the isotopes, how common each version of those isotopes are. It averages them all based on their percent abundance. So when we are looking for molar mass, we are going to take the entire compound based on how many there are. In this case, for salt, NaCl, there's just one of each. And so we're going to start by adding that together. So we have 22.99 plus 35.45. So that's going to give us a molar mass of salt that is 58.44. Now, when we're looking for a percent composition, it's fairly straightforward. As you can see, the formula here is just how much the element is contributing to the overall mass and then divided by the overall mass. So thinking about this, from sodium contributed 22.99 grams to the entire mass, which was 58.44. So just like when you're calculating your test percent, part over whole, we get that times 100, and that's going to give us 39.34%. I'm just going to round to the hundredths place for all of these. You do not have to worry about sig figs here. So just two numbers after the decimal is what I would like. Next, there is the percent of chlorine. Now there's 2 ways you can figure this out. The first way is just the same way we did sodium. So we would take 35.45 divided by the entire mass, 58.44, times 100, and we get 60.66%. The other way we could have figured that out is that this should equal 100. So if we take 100% minus our first percent, since there's only 2 things, we would have gotten the exact same answer. So if you find the percent of 1 and there's only 2 things, you can just subtract that from 100 to also find the percentage of the other element, because the sum should always be 100%. All right, now looking at our next example here, we have 2 elements again, but there's not one of each. So looking at the periodic table, the molar mass of aluminum is 26.98. But there's 2 of them. So overall, it's contributing 53.96 to the entire mass. Sulfur has a molar mass of 32.07, but there's 3 of them. So that contributes 96.21 to the entire mass. And then we want to add that together, figure out what the overall sum is for our compound, which should be 150.17. And just like before, we're taking part over whole. So we're taking the part of mass that aluminum contributes, which is 53.96, divided by the entirety of it, which is 150.17. And then similarly, we'll take 96.21 and divide that by 150.17. We should get, if you want to pause and try to calculate on your own here, we should get that aluminum contributes 35.93%. And you could subtract that from 100, or you could evaluate the 96.21 divided by 150.17 times 100. and see that sulfur should be 64.07%. Okay, one last example here for percent composition. This formula, we have polyatomic ion. So there's now 3 elements. Sodium contributes 22.99 for its mass, but there are 2 of them. So in total, 45.98. Carbon is 12.01, but there's only 1, so that's just 12.01 contributed. And oxygen is an even 16, and so that contributes 48. Adding those all together to get our molar mass for the entire thing, it's 105.99. So just like before, we're going to plug these in. The difference is that there are now 3. So once we find one, if we want to find the other, we can't just subtract it from 100. We would need to subtract the first 2 from 100. So I think if there's 3, it's just easier to calculate them all. So I'm going to let you pause the video and try to do that on your own, and the answers will pop up here in a moment. Our first percentage for sodium should be 43.38%. For carbon, it should be 11.33%. And then the final one for oxygen is 45.29. And these should still add to be 100% total. We shouldn't have it deviating from 100% for the sum of all of our percents. The main benefit of percent composition in practicality is if I'm trying to figure out how to extract, let's say, sodium, if I'm trying to mine for sodium, I want to figure out what compound that I have to dig out of the ground is going to give me the most percentage of sodium if I'm going to put in the labor of trying to extract it. So this helps kind of distribute, and also will help us when we get into figuring out formulas, just based on the ratio of mass of each element. That is percent comp.